Hello everyone, my name is Dr. Vile. Welcome back to my YouTube channel for A-Level Chemistry. The purpose of this channel is all about helping you get ready for your A-Level Chemistry exams. And with that in mind, this video is going to focus on how we tackle a back titration, which is a very specific type of titration. If you find this video helpful, remember to like it, subscribe, share with your friends, and keep checking back for more content. So I'm going to actually pull up the question to start with, and then I'm going to talk you through how we deal with a back titration. So you may find, if you have already revised this topic, that what you want to do is actually pause the video at this point and have a go at the question that's on the screen, and then watch the rest of the video and check that you did it right. Remember, there are different ways of tackling these problems, so don't worry if you used a slightly different method to me, that's not a problem. Let's have a look at the question first, and we'll highlight some of the key points from it. So it says a student was asked to determine the mass in grams of calcium carbonate present in a sample of chalk, and you're told that the chalk has a mass of 0.125 grams. And the student placed the chalk sample in a 250 ml conical flask and added 50 ml of 0.2 molar hydrochloric acid. Now, the volume of the conical flask is kind of irrelevant, to be honest, looking at this question. We don't need to worry too much about that. But what they've effectively done is they've taken the chalk that contains calcium carbonate and they've reacted it with an excess of hydrochloric acid. So that's more acid than we need. And once the reaction is finished, they've then titrated any of the excess HCl with sodium hydroxide, concentration of which was 0.25 molar, and it required 32.12 milliliters of sodium hydroxide. And we're going to have to work backwards to work out how much calcium carbonate is in the chalk. Okay, so let's start off by writing out the balanced chemical equations that we're going to need for this. The calcium carbonate, CaCO3, reacts with HCl. I'm going to balance this in a second, forming calcium chloride, CO2, and water. Metal carbonate plus an acid gives us salt, carbon dioxide, and water. To balance this equation, you need 2 lots of HCl. And after that, everything is balanced. So the key thing here is that 1 mole of calcium carbonate reacts with 2 moles of HCl. We'll come back and need that later. We also see that the excess HCl was reacted with sodium hydroxide. That's an acid plus a base, gives a salt and water. And that's already balanced, and it's in a 1-to-1 ratio. So we're going to need this later, so I may refer back to this slide just a few times. Okay, so that's the first thing. You need to have balanced chemical equations. If they're not supplied in the exam paper, it might be that they expect you to write them out because they are equations that you should be familiar with by A-level chemistry. These are GCSE equations, so it would be perfectly fair game for them to expect you to be able to work those out. Okay, so I've labelled it into 4 steps here. The second step is to calculate the number of moles of sodium hydroxide that was required to neutralise the excess HCl, and therefore we can determine the moles of excess HCl. Okay, so we're going to go into the question and I'm going to highlight the bits that we need. We're going to need the concentration of the sodium hydroxide, highlighting this in yellow, which was 0.25, and the volume of the sodium hydroxide, which was 32.12. So the formula that we need is N equals C times V over 1,000. I'm dividing by 1,000 to make sure the units are consistent because the volume's in milliliters, the concentration is in moles per decimeter cubed. So the concentration is 0.25. Times by the volume, which is 32.12, divide it by 1,000, and that comes out as 8.03 times 10 to the minus 3, and that is moles. So that is the moles of the NaOH. And if we go back a slide, which it's not letting me do, but never mind, on the previous section in the video, we saw that the NaOH reacts with the HCl in a 1:1 ratio, and therefore we have 8.03 times 10 to the minus 3 moles of excess or unreacted HCl. So we will come back to this number. Calculate the initial number of moles of HCl. So to do that, we're going to use the same formula, N equals C times V over 1,000. Get the highlighter pen, I'm going to do this in light green. And the initial moles of HCl relies on the 50 millilitres and the concentration being 0.200 molar for the HCl. So that is 0.2 times 50 over 1,000. And that comes out as 0.01 moles of HCl that were there originally before the reaction took place. Then we calculate the moles of HCl that had reacted with the calcium carbonate. So we started off with 0.01 moles of the HCl, and then you subtract the amount that was unreacted, so that would be 8.03 times 10 to the minus 3. So this is your initial moles of HCl, and this is the unreacted HCl. And if you chuck all that into your calculator, you end up with 1.97 times 10 to the minus 3 moles of HCl that had reacted. So calculate the number of moles of HCl that had reacted with calcium carbonate, and hence the moles and the mass of the calcium carbonate. Well, if we remember back to the very beginning of the video, when we put up the balanced equations, we had 1 mole of calcium carbonate reacting with 2 moles of HCl. So if we know the number of moles of HCl, to work out the moles of calcium carbonate, we have to divide by 2. And that comes out as 9.85 times 10 to the minus 4 moles of calcium carbonate. And then to work out the mass of calcium carbonate, we have to times by the molecular mass of calcium carbonate. So we have to times by 100.1. And then that comes out as 0.0986 grams when given to 3 significant figures. And another question might here then ask, well, what is the percentage of calcium carbonate in your chalk? And what you do is you take your 0.0986 and you divide it by the mass of the chalk, which is 0.125, and then you times by 100. So in this, for instance, the calculations would show that the chalk contains 79% calcium carbonate. Anyway, I hope that video was helpful in terms of explaining how to do a back titration and the calculations. Please keep checking back for more videos. Remember to like and subscribe. Thanks everyone. See you all soon.